Okay, we're coming towards the end of the exam here. We're on question 11. There's one more till the end. Question 11 is asking us to determine the intervals on which my function f of x is continuous. Okay, note that our function here is a piecewise function, and we are splitting up the expressions at 0 and at 2. Okay, so based on each of these types, right, we're going to say, are these going to be continuous or not? And in particular, I'm likely worried about just the 0 and the 2. But if these functions have a discontinuity, then I need to worry about it at other points as well. Correct? So here, I'm really worried about 0. I'm really worried about 2. But maybe these functions have a discontinuity somewhere, and then I need to keep track of those as well. Okay? So let's figure this out. So first things first, let's look at the first expression. Okay? Is this going to have any discontinuities here? Well, yes, right? It looks like that for this expression here, x cannot equal 3, right? Because then I would divide by 0. That would be a problem. Now, does this matter for the region here, for x being less than or equal to 0? No, certainly not, right? So 3 is not less than or equal to 0. So right now, I don't have to worry about that guy, right? It doesn't fit the region that this function is defined on. So 0 is the only point I got to worry about right here. Now, the next function, or the next expression of my f of x function, right, is x squared minus 3x. Well, this is a polynomial. Polynomials are continuous for all values, so I'm not really worried about anything else. But I am worried that at 0, these things might not go to the same point, right? So for continuity, I need those left and right side limits to be equal. I'm worried about that. So 0 is for sure on the list, yeah? Same thing here. This is a polynomial, not a worry, but I do stop at 2. Looking at this guy, I have a worry at x equals 0. But remember, this equation only is satisfied when x is greater than 2. So 0 wouldn't ever be a concern for me, okay? Because 0 is clearly not greater than 2. So again, I'm not worried about 0 there, but I am worried about 2, right? I'm worried about 2 because these expressions change on the function at 2. So 2 might be a point where the limit might not exist. Okay. So let's do a deep dive. Let's take a look at 0. Let's take a look at 2. Let's see if we can prove whether we're continuous or not at those, and then make our entire interval for continuity. So let's start x is 0. So at x is 0, I need to find the left side limit, the right side limit, see if the two-sided limit exists, and then also find the y value and see if those two things are equal, right? That's how we check continuity. So we start with the left side limit. Limit as x goes to 0 from the left. Recall that this is the expression we use from 0 from the left side. So I would go ahead and plug in 2x over 3 minus x. When you take the limit to 0, the top, right, would go to 0, the bottom would go to 3. So this expression just goes to 0, right? 2 times 0 is 0, 3 minus 0 is 3, 0 over 3 is just 0. We do the same thing on the right side. The right side would be this expression, right, for x values greater than 0, which is from the right side. So you're going to do x squared minus 3x as your expression. You take the limit of that, you get 0 minus 0, which would just be 0. Okay. This means that both sides are the same, which means the two-sided limit of my function would also equal 0. Cool. I have a limit. Do I have a y value? Well, what is f at 0? Well, I look and I say, all right, this is when x is equal to 0, right? So I'm going to use this expression. So we plug in 0, and what do you get? You get 0. Okay, so all in all, the limit as x goes to 0 of my function is also equal to the height at that value 0, and those are both 0, right? So since the limit and the y value are equal, they have the same value, we can say f of x is continuous at x equals 0. Okay, cool. So continuity at 0, guaranteed, right? Found the limit, found the y value. Those were the same. I'm continuous. Now we go ahead and do the same thing, but for the second point, right? So at the second point of concern, which was 2. Now recall, I need to do the same thing. Find the left side limit, find the right side limit, find the y value, see if those are going to be the same. However, what we should notice here is before I even do the limit, I actually see on the function that f of 2 doesn't exist, right? So if you look at this, there's no point where x is equal to 2 on the graph, right? There's greater than 2 and there's less than 2, but there's no actual equals 2. So if you don't have a y value, then you definitely can't be continuous, right? Because the rule is your limit and your y value need to both exist and then be equal to the same thing. But if one thing doesn't exist, there's no way it could equal the other thing then, right? Because it doesn't exist. So f of x is not continuous at x equals 2 because of this, right? And I don't even need to check the limits, although maybe you went ahead and checked the limits and maybe that was of concern too, but I'm not going to waste my time there, right? I don't need to do that if I recognize that the y value doesn't exist already, okay? So kind of using this logic in our favor. Now, all in all, I need to make my interval, right? So the question was determine the interval or intervals where I'm continuous. Well, we said that everywhere other than 0 and 2 would have been good. And then I checked 0 and 2 and I found that 0 was all good. And then I found that 2 was not good. So therefore, if I want everything up to 0, right? 0 is good, but I can't have 2. So everything other than 2 is what I need to do, right? So your interval, if you need to do everything other than 2, you would go negative infinity up to 2. And then I would do in union with 2 to infinity. Basically, I'm jumping over the 2, right? I'm saying, hey, I don't want to include that. I'm going to jump over it and I'm going to keep going. So this would be the interval that you're continuous on. Note here that I'm using parentheses, so I'm not using a bracket. Remember, brackets are inclusive. That means they include those points. So if I was continuous at 2, then you might want to like include a bracket. But I'm not, right? I'm not continuous at 2. So I'm putting the parentheses. And then by our notation itself, we never include infinities with brackets, right? So infinity itself is really not like a defined value. So you can't use a bracket and say you're at infinity because you're not at infinity, you know? So that's kind of down the rabbit hole of what we've already talked about with infinities and how that works. But hopefully this makes sense. We looked for the points of concern. We found that really only 0 and 2 were of concern. And we did the flow of finding continuity by checking the limits, checking the y values, and seeing if those are equal. Okay? Perfect. That is question 11. Let's look at question 12.